I'm gonna, since I'm driving, I'm gonna use this like this.
It is a hands-free state. Everyone driving out there, you cannot use your cell phone.
You still hear me? All right. Hi. I am Riley. I am an SRE at Major League Baseball. Any baseball fans? Go Nats. I hate you all. I'm a Mets fan, and it's been a sad, sad time to see the Nationals do so well. But to be fair, Anthony Rendon is awesome. I'm on Twitter at Riley Berton. This is...
I'm Theo Schlossnagle. I do distributed system stuff, and particularly I do not do APM.
So we're going to talk about APM at Major League Baseball. What happened earlier this year, and sort of the situation we found ourselves in regarding APM. We were a big APM user, and how we sort of dug ourselves out of the hole we found ourselves in. We're going to talk about some SRE stuff. If you have questions or comments or anything, we have a talk room on the Slack here at Monitorama. It's called Talk Riley and Theo. If you want to drop, you can also find the link to these slides in there and ask any questions you want, or feel free to shout while we're going if you have something pressing. Okay, the problem. So I started at Major League Baseball in January of this year, late January, like January 22nd of this year. And I got there, I spent the first month, about the first month, automating DNS, like completely unrelated to APM. And we had a terrible DNS system and whatever. There's a new one and it's great. So during that time period, however, we were having these discussions with our old APM vendor about renewing the contract for APM. So we're a big APM user, we love it. We use it across the board for everything. And it wasn't going great for a variety of reasons, not the least of which was the value derived from the cost of the APM system, right? And so sometime in, I think, late February, I was asked to, what it would take to replace APM vendor with something else, another APM vendor or something we wrote or something open source or whatever it is, right? And so I drew this. Can you see that? I drew, it's kind of dark. I took a picture of the whiteboard. I drew that on the board, like sort of off the seat of my pants. I went, yeah, let's just do that. And then I sort of forgot about it. So then a month later, the talks with APM vendor fell apart, and I was asked to write that thing I drew on the board. And so the scary part here is that about 2 weeks after the talks with the APM vendor fell apart, it was opening day of Major League Baseball, which means all 30 teams play. There are 15 games being streamed live. It's one of the biggest days for Major League Baseball in terms of the advanced media division. So we had to have visibility. Luckily, the contract with APM vendor didn't end until the next day. So we had visibility for a day. And then we were blind after that. So until there was a replacement, for the rest of the season, we would have been blind. The first data in the new system started appearing 6 days later. So in 3 weeks, we completely replaced our APM system. And this is what happened. Okay. There's a bunch of lessons in this talk. And this is the first of the lessons. And the lesson is, don't attempt to write an APM system in a few weeks. But if you had to, first of all, we need a couple of things from APM, right? We need metrics, right? This is just the data that's derived from all the tracing data that's coming in via the APM system that has latency information and has request counts. You know, it has the stuff that you expect to have an APM system, what the CPU looks like, what the memory looks like on the various services, et cetera. We also need traces, right? We want to be able to deep dive in certain cases when something looks weird, it's really slow, or it has errors, right? We need to be able to see that trace data. And we also need logs. We were already collecting logs via ELK, so that sort of problem was already solved. Okay, so step one, we have to get the data. So In parallel, I asked a bunch of Java and Node.js engineers to go look at open tracing and get that working. I estimated the total sort of request volume that we see at Major League Baseball, and go ahead.
Yeah, how many people think it works to ask a large engineering group to go do something that they didn't plan to do?
One
Yeah,
guy.
well, one guy. All right, okay. You may be Hercules in that group.
They were actually really, really helpful. They made a really good effort at trying to get open tracing working. And well, I'll get to that in a second. But we also made some Terraform to stand up a Kafka cluster based on some estimates, right? So now we have a data pipeline, as it were, right? And so I just redrew this to make it easier to read, which is the same thing that I drew on the whiteboard, right? So this is where we thought we started, right? But open tracing had some issues. It was hard to work with. We couldn't just drop it in. So we're coming from APM vendor who had a -- Java agent jar, and it would just run and gather everything, and everything worked. That's not actually true in the open tracing world. It didn't have the same coverage. It didn't actually work without some code instrumentation, right? In some certain places we had to drop spans in, and for the stuff that it didn't pick up automatically, and it didn't just work easily, and it was actually a pile of work to get it to operate.
I definitely don't think that's a knock against open tracing as
No, not
a
at all.
design or anything like that. It's really a maturity life cycle thing. It's getting there. 2 or 3 years from now, open tracing will just be a feature flag on pretty much every language, I think.
Correct. And the issue here with us is I would love to have gone this way, but we were pressed for time, right? So this wasn't really an option. We had too many libraries, Spring Boot 1 and 2 and Tomcat and older stuff, and it was just a lot of places to fold in the code. And it would have taken too long. So a colleague of mine discovered Elastic APM. Problem solved. So Elastic APM works exactly like the APM vendor thing works. It's -- Java agent, so that works great. It covers most of the surface area of HTTP and client and server, which is great. Most of our database operations were all captured. You have to run a dedicated APM server, big deal. And it can output to Kafka, which was perfect for our use case. And this is an important point. I just added this morning, but we trace 100% of the time for everything. And this is going to come up later on why that's important. So every single transaction that happens in any service in Major League Baseball is traced today. Everything, every span, every transaction, everything is traced. And we get all the data all the time.
As a side note, we do the same thing at Synchronous.
Right. Okay. So we drop in an APM server. We have the Elastic APM agent on all the clients, and that works great. And the data is flowing into Kafka. And you're probably asking yourself, why not you just do this? Like just use the whole Elastic APM stack. And the reason really is cost, right? That these trace documents are actually quite large. They're 4 to 5K in some cases. You get stack traces, and it's a lot of data. And if you try to jam all that into Elasticsearch and it gets indexed, that gets very large very fast. It gets very expensive very fast. 2, we love Elastic. We use it for logging, but we've had a lot of operational difficulty running Elastic, and we didn't want to carry that forward to run APM in the same way, right? And it's just another form of vendor lock-in. Right? By picking that stack, we've picked that stack, and now we are locked into Elastic APM instead of APM vendor. It's the same problem. We didn't want to be there. So now we have data, and this is sort of a snippet of what data looks like coming off of Elastic APM. It's just a JSON document, and then there are related JSON documents that attach to this, et cetera. Okay? Cool. Lesson 2. The engineers, at least at Major League Baseball, probably universally want their data collection to be automatic. Instrumenting the code is quite a heavy lift, especially if you're dealing with legacy services that aren't maintained anymore or nobody knows who owns them. Getting sort of 100% coverage when you have to go type in span annotations in the code is probably never going to happen. You're going to get spotty coverage, and it's much better to have some external thing, whether it's a sidecar or whether it's a Java agent or whatever it is, doing your instrumenting for you. That's lesson 2. Okay, now we have data. Are we good? We're 10 minutes in. Perfect. Okay, now we have to process the data. So we're back to my diagram. What before said processing application was eventually named TraceMate. And this is the only piece of code in this whole entire stack that I wrote. Everything else was out of the box. Tracemate is a C application, and it basically is a glorified JSON parser. It just parses all the JSON coming in at high speed, and it synthesizes metrics out of this information and tags them with various information based on the trace data coming in. It counts a bunch of stuff. It creates distributions out of a bunch of stuff. It does one interesting thing, which is it does a tail-based sample of the transaction data and decides when to send data off to the distributed tracing system. And it spews time series out somewhere else, just like the diagram, right? So for distributed tracing, we just did the simplest thing that could possibly work, which is an old boss used to say all the time. We save every trace with an error anywhere in the trace. So if I have a large distributed trace across 10 services, and an error happens in service 3, span 15 or whatever it is, we save that whole trace all the way across. So we have the whole thing, and we can go spelunk into it and figure out what went wrong. We also save every trace that is slower than T, where T is defined by service environment, right? So the Stats API may decide I want a 500 millisecond boundary on my trace data, and anything slower than 500 milliseconds, save the trace for me because it shouldn't go that slow and I want to look at it, right? It works well in practice, and it keeps the data volumes low enough to be manageable. In the future, since we own this pipeline, we can actually change our mind about this and decide we're going to do some kind of more sophisticated sampling to pick some of the smaller ones, or the faster ones, I should say. Okay, so here's the trace, right? It's in Jaeger. We shove all the trace data in there, and this is the Stats API. The Stats API, for those of you who don't know, is what you know as StatCast. When you watch a baseball game and you see how far the home run went, that's the Stats API. This is, I don't know, some ball, and that is done clearly in a waterfall pattern and is bad. Okay, just I need to make a quick aside about aggregation here. I think we've decided as an industry that storing distributions for latency is a good idea. Everyone agree with that? Distributions for latency? Yeah? No?
Anybody here use Prometheus with less than buckets at all? Anybody use Prometheus? Okay. The histogram support in Prometheus with like less than buckets where you count things up and you can ask. Not too many.
Okay.
You should do that.
Should do that. Distributions are great. It lets us keep a lot of information about the latency profiles of our services, and it's great. So don't sample this data. There's no reason to sample when you're doing latency distributions. You can just keep all of the samples.
All distributions everywhere, no matter which product you're using or the method they're using, are effectively as expensive as counting things, which for computers is very, very cheap. So doing 100% sampling of something, it's like, man, that's a lot of things to count. Well, that's what computers do. So you should count all of them, even if you don't save the trace data for everything, like the actual latency data that you're trying to manage to, you should sample 100% of that and store that in a distribution. It's no more expensive than sampling into the distribution.
Correct. So the important point here is that this data, that we're collecting all this data, and we're eventually going to use this to feed SRE initiatives, right? SLOs and SLIs. And if it is wrong, we're going to make wrong decisions based on that.
I have a story. I was out with not a customer, not a prospect, out with an old colleague, and they were telling me the story about their adoption of SRE into their organization, and they were super fantastic. And there's their kind of 3 stages of adoption, which I helped them learn. There were actually 4. But the first stage is you convince your organization that SLOs, SLIs, SLAs even are a good idea, right? You set goals, you set performance goals, you set objectives, you set indicators that tell you that you're delivering the quality of product that you expect. You align your organization around those and you win. Right? That's the first step. Second step is like, oh crap, we don't have any data. Okay, so I need to go get the engineering group to instrument everything that we need, which is not a lot of work actually, to measure all of those things that we want to establish indicators against, right? So, okay, now we have adoption, we have data coming in. Now we got to choose numbers. Of course, it's 99%, and of course it's 250 milliseconds, because I read that in a book somewhere. Of course, those numbers are perfect for every organization, right? And then that's the third step, and everybody profits, right? Well, so it's kind of weird. I call that Ouija SLOs. Like, you just kind of trying to find the dead person that told you that was true. So the real problem is those numbers are parameters in a system, and they need to be tuned to business objectives. The entire purpose of SRE is to enable the business to perform better, right? You're using a data-driven approach to make your systems more resilient, higher quality, deliver better service so that your business achieves better outcomes. Okay, so here's the story. They're using Prometheus, set up their buckets. They decide on their percentages, and one team chooses like 99.5%, needs to be faster than 700 milliseconds. And they're tracking it over time, and it's coming in at like 720 milliseconds. And they're like, well, we just can't get it lower than that. We're just understaffed, right? I mean, we have an objective. It's 700 milliseconds, and we're coming in over that. They made hires. They made architectural changes. The Prometheus bucket was from 500 milliseconds to 1,000 milliseconds. There is no 700 millisecond in there. Like, that's a complete lie that it came back at 720 milliseconds. It's 720 milliseconds plus or minus like 220 milliseconds of error. Like, it could have been 501 milliseconds, and it's just misreporting at 720. And the interesting part is that the engineer that set it up was like, well, these are estimates. Of course, we already know that. I don't need to do better than this. The person reading the graph didn't agree with that. The person making the budgeting decisions didn't agree with that. They all made hundreds of thousands of dollars of investment to optimize a number that wasn't the right number. So I've been on stage for years telling people to use histograms for things. And I had temper tantrums before. Now I'm using dialogue, like narrative. Like, these people blew like $300,000 or $400,000 annually recurring cost to fix a problem that didn't exist because they misdefined it and mismeasured it. It's pretty awesome, because when you go back to the original stage where you got corporate buy-in to SLOs, try telling it that way. It's a pretty stark problem. So there is a solution to that.
Yeah, we didn't want to get that wrong because we intend to make decisions based on that. So, where were we? Oh, so so we want to store distributions, right? We've decided distributions are a good idea, and we're going to store them, and so we have a couple of options for storing these. One is Prometheus. We just talked about why that doesn't work. It's actually extra hard in this particular situation because you have to predefine your buckets, and we have services that are so disparate in latency profiles that it's really difficult to define one set of buckets that makes sense for all the different services at Major League Baseball. Some of them are really fast. Some of them are slow reporting services. One set of buckets, we either have to be thousands of buckets, which times thousands of services and endpoints, which would make Prometheus sort of slow down to a crawl, or we'd have to compromise about what we're measuring, which wasn't ideal. So Prometheus is out. InfluxDB does not have a native distribution storage. It has a sort of add-on called Flux that will process the data as on its way in and create percentiles, but that precludes me from changing my mind about what percentiles I care about. So that's out. Datadog had a white paper out recently called DD Sketch, which apparently they're using internally. I'm not sure how much of a sketch it is, but I don't think this is exposed under their custom metrics yet. I think it's only available under APM. This is more along the lines of what we would need, but I don't think it's available for general use yet, so that's out. And that leaves Circonus, which has, for years, for a long time, had a log linear histogram with very well-defined error bounds of like under 4%, right? Mm-hmm. So.
And that's open source, and it's in all sorts of different languages. So that's in C, there's a Go one, a Java one, all that kind of stuff, Node.js, everything. So if you want to track a distribution and you want to understand the error boundaries, like, go to GitHub and solve the problem. And it's super fast, and it's free.
So we decided to use that. And the bonus is that Circonus has a Terraform provider, and that'll come up later about why that's important. Okay, so this is all of the transactions for the Stats API in production from April 7th when we first started getting data to October 8th when I made this slide. Each time slice in this graph is 12 hours of a giant heat map. Anyone have a guess of how many samples are in this graph? Guesses? No, I'm going to tell you in a second if you don't want to guess. 10 billion samples in this graph.
And from a cost perspective, like, it's less than $1 to store that data and analyze it in real time. Like, there's not an excuse to sample, and there's not an excuse to kind of swag numbers. So if you're going to be making a greater than $1 financial decision on the data, it's worth probably investing $1 to store the data accurately and be able to report on it.
Yep. Okay, cool. All right, so now we have the whole thing basically filled out. We have Circonis for metrics, we have Jaeger for traces, we have Elastic APM on the way in, we have Kafka in the middle, and we have one app we've had to write, which is called TraceMate, and all of this was done very quickly. So lesson 3 in the story is now control your data collection pathway for APM, and I would argue for regular metrics collection. It is the cure to vendor lock-in. Because we have open source on the front, down through Kafka, we can actually change our mind at any time. If Circonis ends up not being the right solution, 6 months from now, a year from now, I can funnel this data really easily somewhere else, or somewhere else at the same time. Like some team inside Major League Baseball can decide, I'd like to use Honeycomb to analyze my high cardinality user information coming out of my connected devices. And we can just take this trace data and fire it at Honeycomb for them. And nothing else has to change. They just work the same way.
And I will say from like a vendor perspective, we invested in a lot in making our ingestion pipeline secure and reliable and all of that. And like Datadog and SignalFX and Wavefront, all of these, and Honeycomb, I'm sure, all invested in a really solid pipeline. It turns out that our most successful customers are people who do the pipeline themselves for exactly that reason, is that they can tell us to go pound sand. We're not an APM vendor, so we're clearly not the APM vendor, but I can imagine everyone playing forward a scenario with tight timelines and large costs and how that argument goes. Like when you own your own pipeline, like that argument's super easy because the vendor in this case, I would have no power at all, which of course from a sales perspective kind of sucks, but I think from a health of how you use a product, knowing that you can switch. This is one of the most beautiful things about, anybody here use CDNs for anything? You know how hard it is to switch CDNs? It's not, right? Like if you design that up front where you can just flip from one CDN to another, like people are just like, well, it's gonna go up. And you're like, oh wait, you're not serving any % of my traffic as of 15 seconds ago. Yeah. I switched it all to Fastly. Oh, I switched it all to Akamai. Yeah. Like that's really common. You should be able to do that with all of your tracing, logging, distributed tracing, event data, telemetry data. There's no reason that you couldn't have that complete freedom to switch.
Absolutely, and we actually use this already, and I'll get into that a little bit, for evaluating other stuff. In terms of APM, and we've evaluated Stackdriver Trace in production, live, while we're sending data into these other systems. We just also send it to Stackdriver and check it out, because we can do that, it's easy. Cool. All right. Step 3, we need to actually look at the data we've been collecting. So we use Terraform for this. We use Terraform for a lot of stuff inside baseball. This is just another thing we can Terraform, which is great because it just fits with our current workflows. So all the services that exist under this new APM system get the same basic dashboard, which is probably true of most APM systems unless you go messing around with it. We generate all visuals just based on a list of service names and a small set of variables. We haven't automated this yet. It's more of a GitOps workflow at the moment where a team will go in and say, I'm onboarding a service, and they'll make a pull request and add their service name in there, and then we run Terraform, and they suddenly have visuals, right? So this is what a bad slide looks like. This is what a dashboard looks like. In the system, we got like latency at the top. They have an AppDex index because this team cared about AppDex. We have throughput on the top right. We have a heap map in the middle, some Java statistics on the right, and then like errors and top URLs on the bottom. We also provide them a link, a jump-off point to get to their traces, right? So at the bottom left, and I know you can't read that, it's like a link out to Jaeger for the last 2 hours, 2 days, 2 weeks, based on this service, right? And if they click that, they get right to Jaeger, right to that service, and they can look at the traces, right? And this is the stats API and the research tool having some slow stuff, and they can look at what's going on directly, right? We also get log correlation out of this system, which is sort of the best feature. You just have to set an environment variable to turn it on, and then once it's on, Elastic APM will spit out the trace ID into the logs, all the logs, across all of the services, which is awesome because then when they're debugging something in Jaeger, if you didn't know this, you can go into the YAML for Jaeger if you're running it on Kubernetes, and you can just add a little link in there that says, search this trace ID in Kibana, right? And they just click that, and they get every log across every service that happened to be involved in this transaction. And it took seconds to actually set that up. But what else can we generate? Well, this is sort of where we get into more SRE work and why having distributions is very, very important to us. We can actually let the teams define, by working with the product manager, by working with the engineering team, define sort of their thresholds in this little Terraform document, and that's all they have to do, is tell us, well, this is our threshold, this is our percentile, and for various different things, and this is our success rate, and et cetera. And then we can generate them, error budgets, right, and latency profiles, error budgets for responses, right, and show them exactly how they're doing versus their expectation.
And I will say the 4 steps of adopting SLOs, that 4th step is refining the parameters for your SLOs. Like 99% in 250 milliseconds or whatever it was in the Google SRE workbook. Probably not right for your service. Certainly not right for every single service you run. So being able to tune that, you do need to identify some golden business signals to align that to, right? You can't curve fit something when you don't have anything to fit. But if you know your business is doing well or not doing poorly, then you can reduce your percentage or increase your latency budgets until it actually has business impact, right? Because the goal of an SLO is to achieve the worst possible service delivery you can, you should do the worst job you can ever do and still have every customer that you need to be happy, right? You want to set the bar as low as possible, because the lower you set that bar, the more you can invest in developer velocity, the more risks that you can take in deployments, all of those things, right? It's not like you're just being lazy, it's you're shifting that opportunity somewhere else. So being able to dial those back is really important, and you need to be able to dial them in kind of interactively. You need to be able to look at the past and say, yeah, we did 99 and 250. What would it look like if it was 99.3 at 700, right? And be able to tune all those parameters and fit that in with business outcomes. And then you get to parameterize that.
Right. Cool. Yeah. But what else can we generate? We also generate we let the teams call out interesting URLs, so they have certain URLs in their services that are more important than others. They may not care what the login/login URL looks like, but they might care what API v1 Teams looks like, right? And then we can generate them sort of a small dashboard that's focused on that URL for that service, for that environment, and then they can sort of drill down into that if they need to. So we also have other interesting cases going on inside baseball based on this data. Since we have this rich trace data about every single thing that happens on our platform flowing through Kafka, we can do all kinds of stuff. We have teams that are using KSQL to write SQL statements across the trace data to find what user is getting a high percentage of 404s on this service right now. And they just get a little stream output, and then they can contact that user and do preemptive support or fix problems that exist. There's Kafka Connect apps you can write, which is basically what TraceMate is. It's just not Kafka Connect. It's written in C. Any other stream processing, high cardinality analysis, we talked about that already. We can fork and send data to multiple systems. I've talked about that. We do that today via sending it to Stackdriver logs or to Stackdriver trace or to whatever else we need to send it to. And we can change vendors on the fly, which is the most important thing. If someone becomes subpar for us, we are free to evaluate anyone else at any time. So this is the final lesson of the talk, and it's for the APM vendors, that your pricing is incongruent with what is possible today in 3 weeks in a little bit of software and open source stuff. We have a system that is basically the entire feature set in no time, and it is an order of magnitude less expensive. And I don't say that lightly. It has one less zero on the price than the old APM vendor solution had to do this. And that's a lot of money. So
if anybody has been to the Monitoramas in the past, there was a really interesting, I think it was a keynote that was done by Adrian Cockcroft at PDX, I think it was 2 years ago, 3 years ago, where he talked about the cost of serverless. I mean, he's a huge AWS fan, blah, 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 everything's gonna go serverless. But sort of that's kind of true. I mean, you can run a serverless application that normally is in a data center and costs, $30,000, $40,000 a year for like $4 a month if you have very, very low transaction volume on that service. Put the data in Dynamo, you do your 40,000 requests a day, which are actually effectively like the free tier, right? Like you can really build a service for almost nothing today if it is not high frequency or high volume, right? So if you can build a service and run it for $4, can you imagine paying like a vendor $3,000 a month or $30,000 a month to monitor it? Like that incongruence isn't new, but it's starting to come home to roost in a really painful way.
All right, that's the talk. I think we have time for a couple of questions, so if anybody has, it's hard to see up top, so you shout. Yep.
So I just want to say that where we are, we have the exact same problem. We're working on exactly the same thing. So this is the most relevant talk that I could have ever read.
Sweet.
But my question is, how do you guys handle alerts? Because a lot of users are going to ask for alerts.
Yes, they are. So we today are leaving alerting up to the teams themselves and how they want to define alerts. Like also all this data flows into Circonis and they can define rule sets however they want. One of the things I started to touch on here in terms of SRE is error budgets. And the intention for us when we get there is to go with error budget burn down rate, right? So when people they get whatever their budget is for the month, and if they're burning too fast, we'll alert then. Otherwise not, because we have an environment at baseball that is mostly Kubernetes, mostly containers, mostly cattle. So we kill them off all the time, and we don't care if we lose, some percentage of transactions or we have some percentage of slow transactions, especially since we're fronted by CDN for most of it, right? So the stuff that's hitting this is honestly sort of cached behind a CDN, and so it's less important that it's slow. It's okay, right? So we're going to go with error budget burn down rate as an alerting approach going forward.
And the vast majority of alerting platforms anywhere in the industry are usually tied to metrics and not so much to logs or traces today. Even like the Splunk style alerting is really after you've turned metrics into logs into metrics, pretty much. So whatever metrics platform you end up using is probably the right place to do the alerting. That's my opinion.
Right. This is not, oh, go.
Very similar architecture.
Sweet.
The decoupling, the option to experiment, swap vendors, very powerful.
Yep.
Just one detail. So in a shop of Java developers, say, was C chosen outside of the obviously high performance application? Why did you choose that language over perhaps something that you didn't really get involved with?
That is a great question. The question was, why did I choose to write tracemate in C and not some other language where there's more coverage? The answer is I'm more comfortable in C, and I only had 3 weeks. That is the answer. It could have been in Java. It could have been in Go. It could have been in anything. In fact, it may be rewritten in some other language. Who knows? But for now, it was just fast. The fastest thing I could think of.
Got time for one more question.
Go ahead. It's the question was, what kind of engagement are we getting from developers about usage of the system and growing it? Quite a bit. Of the Stats API team sort of got on board very, very quickly because they need the most visibility. But we have other teams like Connected Devices, so it's all your Xboxes and Apple TVs that play Major League MLB.TV and stuff like that. They're actually using these systems and like the .NET Elastic APM agent to flow data off the Xbox, and then they don't want to put it in Jaeger. They're going to flow their data into Stackdriver or BigQuery, and then like query it as like a high cardinality storage solution. But it's the same idea. It's 100% trace fidelity of everything that happens on your Xbox when you're watching MLB.TV or something like that. So it's getting adopted at sort of a faster pace than the old APM vendor did. The feature set's slightly different, but slightly better because we have more control over it. I was just about to say that. So TraceMate is not open source, but it may be soon. I'm working on that. So we may be able to open this up and then just let everybody play with it. There's not much or anything in it that's specific to baseball. So it just reads APM, Elastic APM trace data, and makes metrics out of it and makes traces out of it. So we're happy to open source this as soon as we get through all the legal stuff at Major League Baseball. So stay tuned. Thank you.